In this video, we're going to discuss the even and odd properties of trigonometric functions. Okay, so an even function is defined as a function in which f of negative x is equal to f of x, or the y value at negative x is the same as the y value at x. And an odd function is defined as one in which f of negative x is equal to negative f of x, or the y value at negative x is equal to the negative y value at x. So now let's look at these properties and apply them to trigonometric functions. All right, let's look at the cosine function first. So we're going to take t equals pi over 4, which is right here. So we know that cosine of t equals x. And the x value at t equals pi over 4 is root 2 over 2. So cosine of pi over 4 equals root 2 over 2. Now, let's look at cosine of negative t, or cosine of negative pi over 4. So let's find t equals negative pi over 4, which is right here. And we can see that the x value is also root 2 over 2. So cosine of negative pi over 4 also equals root 2 over 2. So we can see that f of negative x, which is root 2 over 2, is the same value as f of x, where cosine of pi over 4 is the same as cosine of negative pi over 4. So this is an even function. So now let's look at the sine function. We can use the value pi over 4 again, which is right here. So t equals pi over 4, and sine of t, we know, is equal to y. And the y value at t equals pi over 4 equals root 2 over 2. So sine of pi over 4 is equal to root 2 over 2. Now let's look at sine of negative t, or sine of negative pi over 4. So at t equals negative pi over 4, which is right here, we can see that y equals negative root 2 over 2. So the sine of negative pi over 4 is equal to negative root 2 over 2. So now we can see that this fits the definition for an odd function, because sine of t, or sine of pi over 4, equals root 2 over 2, and sine of negative t, or sine of negative pi over 4, is equal to the negative of sine of t. All right, so now let's look at the other trigonometric functions. So we know that cosine of t, which equals x, is an even function. And we know that sine of t, which equals y, is an odd function. Now, let's look at tangent of t. So we know that tangent of t is equal to y over x. Now, to provide a quick explanation, because tangent of t involves y, which we know involves negative values because we see here that y is an odd function, we can say that tangent of t is also an odd function. Now, let's prove that. So we can again use the value of t equals pi over 4, and we know that tangent of t equals y over x, and both y and x are root 2 over 2, so we can say that tangent of pi over 4 equals root 2 over 2 over root 2 over 2, or y over x, which equals 1. Now let's take the negative value and look at the tangent of negative pi over 4, which is right here. So we can see that in this case the y value is negative. So this is going to equal negative root 2 over 2 over root 2 over 2, which equals negative 1. So we can see that tangent of positive pi over 4 equals 1, and tangent of negative pi over 4 equals negative 1, which is the negative value of tangent of pi over 4. So this fits the definition of an odd function. Right, now let's look at the secant function. So secant of t we know equals 1 over x. And because this is just the reciprocal of the x function, which we know is even, we can say that this is also an even function. Because when you take the reciprocal of any value, it doesn't change whether it's negative or positive. So the x function is still going to be even. And now we can look at the cosecant function, which equals 1 over y. And again, we know that y is an odd function. So when we take the reciprocal of this function, it is going to stay odd as well, because taking the reciprocal will not change whether the values are negative or positive. Now we can look at the cotangent function, which is equal to x over y. And again, this is the reciprocal of tangent function, which equals y over x. So we can say that taking the reciprocal does not change whether it's negative or positive. So again, we can say that cotangent is an odd function like the tangent function. All right, so now let's look at some examples. So we know that sine is an odd function. So sine of negative pi over 3 is going to equal negative sine of pi over 3. So that's the definition of an odd function. So we can find sine of pi over 3. So let's look at t equals pi over 3. And we know that sine of pi over 3 is going to equal y, and the y value at t equals pi over 3 equals root 3 over 2. So sine of pi over 3 is going to equal root 3 over 2. Now, sine of negative pi over 3 is going to be the negative of this value. So sine of negative pi over 3 is going to equal negative root 3 over 2. All right, now let's look at this example. So we know that cosine is an even function. So cosine of negative 5 pi over 6 is going to just equal cosine of 5 pi over 6. So let's find t equals 5 pi over 6, which is right over here. So the x value is negative root 3 over 2, and we know that cosine is equal to x. So we can say that cosine of 5 pi over 6 is equal to negative root 3 over 2. Now, to find cosine of negative 5 pi over 6, we know that these values are going to be the same. So cosine of negative 5 pi over 6 is also going to equal negative root 3 over 2. All right, now let's look at this third example, which is a bit harder because we have a value that's greater than 2 pi. So first, we know that sine is an odd function. So again, sine of negative 13 pi over 4 is going to equal negative sine of 13 pi over 4. So to find 13 pi over 4, we're going to have to go around the unit circle a few times. So if we go around the circle once, we have 8 pi over 4, and then we have 5 pi over 4 left to get to 13. Let's go 1, 2, 3, 4, 5. So we're here. 13 pi over 4. So t equals 13 pi. So here we can see that the y value equals negative root 2 over 2. So sine of 13 pi over 4 is going to equal negative root 2 over 2. So we know that sine of negative 13 pi over 4 is going to be the negative of this value. So sine of negative 13 pi over 4 is going to just equal root 2 over 2.